Section 11.5, the last section of this chapter, choose the best model for two variable data. So two variable data is simply where you have an x and a y. So it's comparing two things, the height and the length of something, or the speed and the size of something. Anyway, so it's comparing two things. Now, what we've done before is we've simply used a scatter plot and we've plotted those points, and then what we've done is we've used a linear function, and we've used the line of best fit. If you remember, we have done this. So, but what we can do is we can use our graphing calculator. So that's what we're going to do today. Is use your graphing calculator. So for this class, you'll need your calculator. This video is going to be super quick and short, and we'll work together with your calculators in class. So what you need to remember is that a linear function is of the form y equals ax plus b. There are no squared terms, no exponents at all, and that's going to end up being just a straight line. It can be up or down or around, and all of that depends on the values that you put in for a and b, and you're aware of that. A quadratic formula you need, or a quadratic function you need to remember, y equals ax squared plus bx plus c. If you'll remember, that is a parabola. So it's either going to open up or down depending on your positives and negatives. So with the squared term, you're going to end up with a parabola. A cubic function is going to look something like this. So it's going to go down and then up. Wow, I like it when they're pretty. Pretty cool. All right, so if you have a cubed variable in your equation, then you're going to end up with a cubic shape on your graph. And the exponential shape, if you remember, if you've got x as an exponent, then the larger that exponent gets, the larger your number gets very, very quickly. So you're going to end up with a function that goes up very quickly. Now, here's the steps. I'm going to tell you the steps, and then we'll just do it together in class, because I can't show you the calculator on the video. It just won't work that way. So what you're going to do is this. You're going to take in your assignment, you're going to have just a table of data. You're going to take that data and put it into your graphing calculator and graph that. And I'll show you, if you don't already know where those lists are, I'll show you how to put in all of the x's, and then you put in all the y's, and then you simply hit graph. And it will graph, and your graph will have lots of little dots. What you need to determine is, you need to look at those little dots and determine, okay, is this a linear function, or do the dots look like they're pretty much a straight line? Is it going to be a parabola? Is it a quadratic function, cubic, or exponential? So when you're looking at that shape with all the little dots, which shape does it best fit? Because in your calculator, there are options for regression of each of these separate types. So you'll choose either linear regression, quadratic regression, and so forth. So after you recognize which shape it is, you'll press that regression button, and it'll simply spit out an equation. Because if you'll remember, we did the line of best fit with the linear functions, and so you plotted them all, and then you figured, okay, this is our line of best fit, and then you picked two points on that line, and you came up with the equation. Your calculator's going to do all of that for you. I know, please don't throw rotten tomatoes. You could have done that before, but there we go. Now you know how to do it by hand, and you know how to do it with your graphing calculator. Yay! So yeah, that equation is what you're looking for. That's what you're going to want as your answer, and that's it. Quick, easy video, and I will see you, and we'll do lots of graphing together.